Hey everybody, welcome to another const support video. This one's on number of solutions to a system of equations algebraically. All right, so let's go over the idea of it. So if you have two linear functions that are basically put together, you have a system, right? So you're looking at both linear functions together at the same time. And if you have a solution to the system, it just means that you have a x and y ordered pair that is on both of the lines, basically. That's a solution to both lines, not just one. So if they're the same line, basically you have an infinite number of solutions. If they are not the same line, but they are basically parallel lines, they have the same slope, but they have different intercepts, then that would be something where you have no solution because they're never going to cross. And then if they have just intersecting lines, they'll have one solution. So let's take a look at it. All right, let's go. So this is how many solutions does the system have here. So we have this system here, and it's y equals negative 2x. Let's fix that. Y equals negative 2x minus 4. And the other one is y equals 3x plus 3. So if you're given both lines in y equals mx plus b, the easiest thing to do is just to set the y's equal using substitution. And then once you solve, you'll find out if there's one solution or not. So in this case, what I'm going to do is I'm going to just grab a highlighter and show you guys that you can take this y value and replace the y in the other equation with it. In other words, substitute it in, right? Replace it right there. So what you end up getting there is you get the y value is equal to the y value, basically, which is negative 2x minus 4 is equal to 3x plus 3. When you have this, you're going to then solve it. So you're going to basically get all your x's to one side, so add 2x to both sides, and then get all the numbers the other way, so to take away 3 from both sides. And you end up with negative 7 is equal to 5x, and then divide by 5 both sides. And so you can see here that x is equal to negative 1 2/5. Now, it doesn't really matter what x is, but there is an x value, right? Which means that there is a solution to the system. So these aren't the same lines, right? And all that being said, it says to do it algebraically, but I'll show you in a second why I'm laughing. You could plug this x value into either equations and get the ordered pair that is the solution of the system. So the x value is negative 1 2/5, right? The y value is just going to be whatever you get when you plug that in. So if we take, let's say, negative 7/5 and plug it into this one here to solve, we're going to get the answer. So y is equal to negative 2 times 7/5, or negative 7/5, I should say, minus 4. And so that's going to be y is equal to negative times a negative is positive, so that's 14/5 minus 4. Y is equal to 2 4/5 minus 3 5/5. And that's just another way of writing 4 there, right? So you have 3 5/5 wins by how much? And then 5/5 take away 4/5 is 1/5, and 3 take away 2 is 1. So we get y is equal to negative 1 1/5, because negative 3 5/5 is bigger than positive 2 4/5. Anyways, so you get the order pair y equals negative 1 1/5 and x equals negative 1 2/5, right? So ultimately, though, it doesn't matter what the values are, right? This is one place where they intersect, right? This is a solution to both of these lines. This should work on not just the left line, but also work on the right line. If we plugged it in, we'd see that it was true. Let me just plug it in for you, and you can see that it's true. So if we think about this, that's the same as saying negative 7/5 for x and negative 6/5 for y. And so if we plug that in to check it, we'll check it on this other line, make sure it is a solution to the other line as well. You can see that the y value, negative 6/5, should be equal to the 3 times the x value, negative 7/5, and then plus 3. And so if we take a look at that, you're going to get negative 6/5 is equal to negative 21/5. Because 3 times 7 is 21, and that positive times negative is a negative. And then this is going to be 15/5, right? So negative 21/5 plus 15/5 is, in fact, negative 6/5. So you can see that the answer is the same, and it works, okay? All of that being said, all right, you can just solve this system algebraically like I just did, right? We know that this point exists on both lines. There's one solution, all right? But then, you know what? I was laughing halfway through the problem, and here's why. It tells you to solve it algebraically. Do you need to solve it algebraically? No. Just look at it. They gave you both of the lines in y equals mx plus b form. If they have the same slope, but different intercepts, then they're going to be parallel lines. If they have different slopes, then they're going to intersect. And if they have the same slope and the same intercept, then they're the same line. And all you got to do is figure out, are they the same line? Are they different lines? Or are they intersecting lines? If they're intersecting lines, it's one solution. If they are basically never going to cross, then there's no solution. It means parallel lines, same slope, but different intercepts. And then infinitely many solutions just means they're the same line, so same slope and same intercept. So really all you're looking for, does it have the same slope? If it does it have the same intercept? And then just make a choice. So when I look at this one here, we could do all this work over here to get the exact solution. Or you could just look at it and go, they don't have the same slope, because one slope is -2, the other slope is 3, which means they must intersect at one spot. So exactly one solution. For the next one, you don't have it in y equals mx plus b for the top one. You do have it for the bottom one, right? So let's just get the top one into y equals mx plus b. That's the only algebra we have to do. So 5y is equal to 15x minus 40. Rewrite this as the slope-intercept. So you're going to solve for y, divide everything by 5. And you're going to get y is equal to 3x minus 8. Okay, so this is the line in slope-intercept form. Well, they're the same line, right? Y equals 3x minus 8, y equals 3x minus 8. That means there's got to be an infinite number of solutions, right? Because every single ordered pair on one is the same as the ordered pairs on the other. And then the last one here, it says, how many solutions do these two have? Well, when you're looking at this one here, right, you have 8x plus 2y equals 14. And the other one is 8x plus 2y is equal to 4. So they're set up in standard form. So you could just multiply to use the elimination method, right? So I'll multiply this one by negative, right? But when you multiply it by negative, look what happens. You're going to get negative 8x minus 2y equals negative 4. Well, wouldn't both the x and y get eliminated? So is there any way that you could combine these with elimination where both variables don't get eliminated? No, which means this is kind of funky, right? There can't be one solution. There's no one solution to this one, right? So then you might ask yourself, all right, let's put this into slope-intercept form and take a look at what these actually are so that we can start to see what they look like visually in our minds, all right? So if we take a look at these two and we put them in a slope-intercept form, 8x plus 2y equals 4, okay? You're basically going to minus 8x on both of these situations from both sides, right? So that's going to be pretty straightforward. And then you're going to get 2y is equal to negative 8x plus 14 over here. Here you're going to get 2y is equal to negative 8x plus 4. And then you'll notice that when you are solving this, you're going to divide by 2 everything, right, to get the value of y. So we can see the slopes are the same, aren't they? So in this case, you can see the slope is exactly the same. It's going to be negative 4 slope for both of these. But the intercepts are different, right? So if the slopes are the same, but the intercepts are different, these are parallel lines. Okay, and parallel lines are never going to intersect. So what you're basically seeing here is that these two lines have the same slope, they're parallel, they're never going to intersect, which means that there's no solution. When you tried to eliminate it, right, the variables went away, both of them. That means there's no solution. You can't get an x or a y on its own because there's no place where these two lines intersect. Right? So if you try to find the place where they cross, you try to combine the two functions into one, you end up with no variables that exist anymore because there's no place where they cross. All right, that's no solution. All right, and then the next one here, this is when we have one is in slope-intercept and one is in standard form. So the last time they did this, they were the same. I wonder if it's the same again. Let's find out. So this one we have 4y equals 4x minus 8. To get this into slope-intercept form, you're going to divide everything by 4. And you get y is equal to x minus 2, right? So when we take 4y equals 4x minus 8 and we solve it for y, you divide everything by 4 and you get x minus 2. So y equals x minus 2. Notice that when we look at these, the slopes are not the same. One slope is 4, the other slope is 1. And so we know that they're not going to have the same slope, which means they're going to cross at some point. So this is just exactly one solution. And that's it. And that's how you do it.